Going into this project, we had a short list of absolutely mandatory requirements that we knew had to be met if any sort of practical, actually doable project was going to emerge from this work. Let me walk through what those requirements were and remain at this time, and what the status is on meeting them. The first requirement is that the resulting product had to be a complete business proposition. This could not be a concept reactor sitting as a theoretical idea. It could not be a reactor only without the companion power plant. It could not be a reactor and power plant project that was developed without considering where all of the materials, where the fuel, where the processes involved to actually manufacture it would come from and what those would cost. In other words, it had to be a complete commercial, what they call shovel-ready project. And that's our first requirement, and we've accomplished that. The second requirement, at least as important as the first one, is that the resulting power plant had to be NRC licensable, and not theoretically, hypothetically licensable. We have constrained ourselves to only use materials and methods and processes for which a broad body of prior licensing experience and data exist. There is no new technology in our product that the NRC has not already seen in the past. This is the key to being able to quickly license this power plant, and that is the number one question that comes up whenever we're discussing this venture with others. The complexity and convoluted nature of the NRC licensing process is broadly known, and the first challenge that not only did we set for ourselves, but with which we're confronted from day to day at this time, is this idea. Is this a practically, legitimately licensable power plant? And the answer is yes. We've accomplished that. We have stayed completely inside the boundaries of all of the applicable NRC regulations and inside all of the applicable ASME and other standards body standards that are invoked in those regulations, and have done so to the point that we've only adopted methods and materials in scenarios for which deep prior data from testing and operational experience and actual NRC licensing processes exist. The third question is that the combination of the amount of time involved, the amount of money involved, and the realistic appraisal of those for every single component and method within this overall plan have to be practical and make sense from a capital perspective, from an investment perspective. As a for-profit business venture, albeit we have a number of humanitarian objectives we're chasing with this venture, the idea of ridiculously lowering the cost of electricity is astonishing from a lot of people-related points of view. But to make it happen, it has to be a viable commercial venture from a dollars and cents perspective. We've accomplished that. The amount of the total capital involved against the speed of the return on that capital following launch 5 years from now is the first project in the entire nuclear sector that's been put forth in decades that actually does make sense. This is very much a formula that is well within the boundaries of venture capital, private equity, private investment, corporate expenditures, all of the expected metrics are met. This is a commercially viable project. And as perhaps oversimplified as that may seem, those are actually the three defining metrics against which we have developed, planned, and are prepared to move forward and implement this project. Is it a complete plan? Actually, yes. It's the first small fast reactor-based power plant plan, the only one that has ever been put forth. Secondly, is it actually licensable based on using only techniques and materials and methods that already have a substantial body of NRC licensing familiarity, and all of the test and operations data going back historically to validate those to the satisfaction of the Nuclear Regulatory Commission? The answer is yes. We have done that. The resulting product may be a little boring, not particularly exciting to those folks out there who have a very forward-thinking hope for the eventual destination of nuclear power, but it's something. It's a simple, crude, basic power plant that can actually be built with today's technologies using methods that already have NRC licensing familiarity. So yes, it's licensable in the time frame that we're planning. And the third idea, is it a practical, reasonable capital investment proposition? The answer is yes. For the amount of money that's required to get to market within 5 years, against the sales and profit results following launch and the resulting payback on capital, this is an amazingly attractive investment proposition. And by focusing on these three metrics and constraining all of our work, no matter the exciting stuff that we came up with along the way, we have held back and stayed within those boundaries, which is the point that underlies this entire American Atomics venture, is that for the first time in the history of the advanced nuclear power sector, a group of people have actually come together to develop a reality-based project. This is a reality-based project. This can be done, and that's the point of the technology side of it. Now, for specifics, I'll talk a little bit about that right now. Ours is a combination of, first, using a core and fuel assembly and fuel design that is already done. The Department of Energy designed a reactor over the last decade specifically to be NRC licensable. Crew at Argonne National Lab, in working with a crew from Japan and from France, that's funny. I'm going to leave this in just because it's funny. Collaboratively worked around that one requirement to answer the question: can we design a reactor that is constrained to NRC licensable, NRC familiar methods, materials, and techniques that achieves the goal of a simple, manufacturable reactor. And the result of that project is the basis of our product design. And around that, in areas that are not core and not fuel related and not fuel assembly related, specifically with the thermal systems, the cooling systems, and structural systems around the core, we have brought an enormous amount of innovation because we have deconstructed their design in those areas and come back with the idea this needs to be appropriate for high volume mass production at the lowest cost possible. And by using a combination of materials and techniques, especially lost foam and other advanced casting methods, to reduce the number of parts into a very large structure. Actually, at the moment, we're looking at potentially only 3 very large structures making up the entire reactor module. We've been able to distill out about 80% of the cost from the cooling and secondary power plant and structural elements of this reactor design that would normally be there using traditional approaches. And back to the first requirement, every one of these innovations has been constrained to remain within the envelope of techniques and materials that have deep DOE-funded research and operations results. They fall within the appropriate ASME and other standards that are applicable within the NRC licensing process. Although we've innovated, radically innovated, we've held those innovations within that requirement. Nothing that we've done beyond what Argonne did with reactor design originally takes our product outside that boundary. We're clearly still within the boundary of NRC licensability on a very fast track. Insofar as the technology is concerned, that is, in a broad view, what's important here. We're the only ones that have ever done that. There are a lot of varyingly real small reactor ventures that have been announced in the past, are currently announced, and are being pursued. Some of them have gotten funding, some of them remain at the conceptual level, but invariably they all push beyond the envelope of actual immediate NRC licensability by staying with a sodium-cooled metal fuel combination and adopting, again, a DOE-designed reactor that was specifically designed to be NRC licensable, and having the entire database of documentation, everything from the fuel irradiation results, the materials irradiation results, to the fluence testing for the stainless steels involved, on and on and on. All of that as the repository of data that we can bring along with our reactor design to the NRC. This is the only actual reality-based, practical small reactor project that's ever been done. And that's a view of the technology side of the business. Thank you.